So, hormones and steroids affect everybody's body in different ways. And you can see this in that everyone goes through puberty and has different body types. Sometimes it affects people more in one way than another way. Even the same sex and everything in the same age. And even when they go through the end of puberty, different characteristics are exaggerated to different extents or develop differently. And one might be bigger in one individual than another one of the same sex. Also, insulin and glucagon, the opposite of insulin, kind of work to different extents in different people. Adrenaline, norepinephrine, all those ones have very hugely different effects in different people. We don't fully understand them. And they also all interact with each other. And hormones and steroids are very important because we have your cortisones and corticosteroids, which are used to treat a bunch of inflammatory conditions. And better understanding them could lead to better treatments for inflammation in a whole bunch of ways. Besides the ones for inflammatory ones, they all have to do with the immune system. Estrogen and testosterone, having too much or too little can change how well your immune system works. It can also be used to fight cancers. Estrogen can fuel breast cancer and can fuel ovarian cancer. Testosterone, testicular cancer and penile cancer in particular. And giving the opposite hormone can sometimes work to decrease how bad the cancer is. So breast cancer giving testosterone or something. It can be used there's also, some people have disorders where the immune system don't produce as much thyroid hormone or other hormones. They have it can mess up the circadian rhythm. Sometimes people have it removed for various surgeries, like you have your thyroid removed because you have thyroid cancer. We have diabetes, glucose, insulin, a bunch of different ones. Then you have people transitioning, and fertility problems, but we don't understand it well. They're relatively a safe treatment for the most part. Or an anaphylactic shock, we use it to treat shock and stuff like that with adrenaline, norepinephrine, and epinephrine. But the thing is, we really don't understand why it's such a diverse reaction from person to person. They generally tend to be relatively safe, though, because the effects are so slow, comparatively, and easy to measure that we can adjust the doses pretty easily, but just find the right doses in the beginning and getting the maximum benefit is hard. So it's always a little off, getting the maximum benefit. There are exceptions when we need to treat it fast, like anaphylactic shock is when you need a fast dosage or something like that. And we also don't really understand it very well because these ones can have, we also, if we understood it better, not only could we give better treatments, we could give better treatments in the beginning, saving money and lives. We could even make transitioning better for people so that people transition more how they want to transition exactly instead of this one hormone that's simple. And if we can deduce why people are different sensitive to different hormones, we can maybe able to make more complex treatments that are more specific for just one thing the hormone does or one aspect that mobile hormones do, not just one. And we can start splitting up what this hormone does and this hormone does better and get rid of the confounding variables. So what do I think affects hormones and steroids? And steroids are a type of hormone. More specifically, well, these are 9 ideas I have that I think we should look into to try to explain the difference. One is body absorption rate by tissue. And different tissues absorb different hormones at different rates. I also forgot to say that they not only absorb them at different rates, they also eliminate them at different rates. So the classic is fat interacts more with insulin and glucagon and liver than other ones, and some people have more fat. But also fat interacts with estrogen more. Testosterone has more effect on muscles. And it's all these other ones, and maybe that explains some of the difference. Not fully, but might explain some of the difference. The next one that's kind of related is cell absorption. So different cells absorb differently. Well, different cells, we always said, absorb different amounts of each chemical and get rid of them. And someone's muscle tissue might have different composition, different cell types. There's actually different types of muscles that work for different speeds, or more like fast but not as strong in the end, or strong but slower to react. Stuff like that, fast twitch, slow twitch. There's about 6 or so types of skeletal muscle. But also, different cells in different people's body might absorb hormones differently, and which makes them more or less sensitive. And that could be a genetic thing, that we both have a muscle cell, but my muscle cell absorbs certain things better than your muscle cell, or worse. And it also might absorb it, because after absorbing, you might get rid of it faster or slower, digest it. Another thing that might be a key aspect, and I just thought of a new one, which I'll put at the very end, is that it might not only absorb, the production might be different. So estrogen, for example, most people say estrogen is produced in the ovaries. That is to some extent true. That's the biggest production in the female body. But it's also produced in fat tissue throughout your whole entire body, to the next most extent. And a lot of tissue produces a little bit of estrogen. Testosterone is not only produced in the testes, it's produced in other glands a little bit, or in a bunch of other ones. And where this production occurring and the distribution of this production might affect how it affects the body, because it might have, if you have more producing it in a certain area, maybe it affects that area more than a person that produces it somewhere else where it affects that area more. Maybe that explains some male-female characteristic differences. Another way the production might affect it, where it might be a place that's closer to you peeing it out, or liver filtering out, or flushing it out, so it doesn't stay in the body as much. So even though you produce the same amount, it gets flushed out more, or it stays in longer, or something like that might be happening. It could also affect the time. Maybe if faster response causes the sequence of events to be different, and faster response or slower response. The next one that I want to do is maybe the time cycle is slightly off. We already know the hormone cycles are important. The menstrual cycle, so your circadian rhythm is partly controlled. Your sense of year with months is partly controlled by it. Your immune system is connected to all those rhythms in your body and more. Your insulin and glucose level depends on the time of day. Glucagon level. All these things. Maybe if you look at it at big time scales, it looks the same. But at the small time scales, it's different. So over a day, we have the same average. But I only produce my one in a very short burst, while you produce it continuously throughout the whole entire day. And cells act, we know from a fact, with the menstrual cycle being the prime example, but also you can look at insulin, glucagon, and much more, that when it's not only is the amount at instantaneous moment is important, and not only that, how long it stays in the body is important, and even the amount previously. It's sometimes important if a hormone in the body is on the rise or if it's going down. Not only the level, but just if it's going up and down. That's important for the menstrual cycle, but also for insulin and glucose production, and for response with fight or flight. Another thing that I think that we should look at is there might be small modifiers. What I mean by that is almost all proteins in the body can have small modifications that make them more or less permeable, or something that can go on and off. These are hard to detect, but maybe not all of your testosterone or anything is the exact same, and it's getting converted ever so slightly, but that somehow adds up to a bigger thing. The next one is how the body fluids act in your body. So sometimes your body might have, for some people have more viscous blood, some people have blood with more sodium or potassium. Some people have more of different types of fluid in the body. You don't only have blood, but you have something called lymph fluids, which is in the lymphatic system. You have fluids also floating around the empty cavities in your body, and all these other fluids. And depending on the properties, they might transport in and out of different places hormones better, or say how long they stay. Or in other ways, we affect the receptors, because the receptors might be more easily interact or less. You can think about this as a little bit of, if you put detergent in water, you can make or soap in water, you can make the dirt flow more easily in the water, but it doesn't bind to receptors as easily. If you don't, it just settles out to the bottom, so it doesn't stay as far. The dirt just gets dirty and settles out the bottom. So you might eliminate it faster, but it also might interact with the receptors better. How well it stays in the fluid, or does it come out fluid? Everything is dependent on all these fluid properties, which really could have widely affected, and how well it interacts with receptors. Body temperature might be affected. People's body temperature naturally fluctuates slightly, and not everyone has the same body temperature, but that might change the sensitivity because it just changes how fast chemical reactions happen. And it also changes slightly what chemicals you have in your body. Ever so slightly, but a lot of hormones take years and stuff to impact, so a slight change actually might be significant. Another one similar is body pressure. For similar reasons, it affects fluidity, but it also affects absorption in different places. The last effect I listed is different nutrients. Some people might have more of some nutrients and not as much of some nutrients, which might affect what your body actually starts producing or how it interacts with it. So if something tells you to make more blood, but you don't have enough iron, you're not going to make more blood than me that has the same amount of that hormone, but I have enough iron. So the amount of iron, if I have an iron deficit, but I have more of a hormone to produce blood, I still might make the same amount as someone that doesn't have as much of that hormone, or something like that. There might be some interaction with nutrients. The last thing I forgot to mention is, I just came to realize while we're making this video is vasculature, which I'll put it down here, and you're pumping. And vasculature, you can appears with like cardiovascular system, it appears with vascular plants or anything, but it's basically all the tubes in your body, from the most commonly hear about blood vessels, but it's also like other tubes like lymph vessels that carry more of the immune system and other liquids, and how they spread throughout your body, which can help really affect how all these things are distributed throughout your whole entire body. Well, I hope and these are just all things that I think we should look at and try to piece together how each one affects it and try to build up a picture from there. Well, thank you very much for listening. Please like and subscribe. It really helps the channel out. I'm trying to reach 1,000 subscribers in a year and 4,000 watch hours, which is really hard, but with your help, I think I can do it. Also, if you have any ideas for future videos, any comments, any concerns, comments, please leave in the comment section below. It really helps out. Thank you very much. Goodbye.